So, can anyone tell me up to which part you have done in last session? Anyone?
I have a doubt.
What? Which part?
No, I have a doubt which is separate.
Okay. Yeah, say now. Whatever doubt you have.
It's about activity question 5.8.
Okay. In 5.8, which question?
The last one.
If the domain of a composite function f composite g is -2 comma infinity, that one?
Right. My question is, why isn't the second option correct?
Okay. Yeah. In the second option, there is x in the denominator, right?
Yes.
So 0, x is equals to 0, the function won't be defined, right?
Yes.
And the interval -2 and infinity contains 0. Yes. Right?
Yeah.
So, sorry. So we know the domain of f composite G what will be? Okay, fine, we'll discuss it.
Ma'am, if you look at the first option,
Yeah.
it also has x plus 2 as the numerator. I actually did not care about the 5x being in the denominator. I cared more about the numerator becoming 0. So the way I was testing this, that the g of x should not be uh, 0 or undefined, because if it was 0, then it would make f of x undefined, because f of x has 1 by x square.
Okay,
And
okay.
and
Wait.
if it
If you consider what is the domain? What do you know by the domain of f composite G, right? So domain of f composite G is it has two property, right?
yeah,
First property is that for all belongs to x should belongs to domain of G, right?
yes,
And the second property is that G of x should belongs to domain of f, right?
yes,
Here your G is given by under the root of what is this?
x plus 2,
X plus 2 and upon 5x, right?
yes.
So if you observe the domain of G won't contain 0, right? because if you put 0 here, then this is not defined, right? Our denominator, this should not equals to 0. If you put x is equals to 0, it will become 0. So gx is undefined at 0.
Okay.
Right?
Yeah.
So it won't satisfy our first property, na?
Yes.
So it won't be the domain of F composite G, right?
Yeah, but only when x is equal to 0, right?
No, but the what question says to us that we have to choose those possibilities for G, right?
Correct.
So if you choose this as a possibility of G, then it won't be happen that the domain will not be -2 and infinity, right?
No, I don't. See, ma'am, the way I try to solve this is
Okay.
when I saw that the domain of f or g, they said it is in the interval of -2 and plus infinity.
Yeah.
And they are not included. So the first thing I did, I tried to include -2. I tried to use x is equals to -2 in all the four options, and
Oh.
I made sure that the g of x does not turn undefined, because that would break the whole thing. And also I made sure that g of x does not become 0, because if g of x becomes 0, then when we put 0 into f of x, which is 1 by x squared, that would become undefined. So those are the two properties that I am aware of, and that's how I try to solve it. And when I try to solve it, I come to the conclusion that the second option, x plus 2 by 5x, when I use -2 in place of x, it becomes 0 in one sense.
Yeah.
And if this becomes 0, then f of x would become undefined.
Yeah, these two things you should do, but you also care about the what is the domain of G, right? Because in F composite G, we first want that our x should belongs to domain of G. Otherwise, the x won't belong to domain of G composite F composite G, right? You should also check these two properties because these are the definition you have defined the domain, right?
Yeah, but the domain is given to us of f of g.
Yeah, a domain is given to us, but if you consider this G, then the domain will not be -2 and infinity. It will exclude 0.
Oh, okay.
So
I
this
get it
is
now.
not the option, right?
I get it now. Okay. I was okay. So the correct way of solving it would be, uh, I
Yeah, the correct
actually
way of solving is this: consider that G from the option and then look what is the domain of F composite G. If it is
okay,
-2 and infinity, then you
okay,
are
okay,
done.
okay, got it.
Otherwise, you cannot say anything.
Oh,
Okay.
I try to solve it the other way around. Thank you.
Yeah. Okay. Good. So we will start our session.
Ma'am,
Is
I
any
will.
questions? Yeah. Just say one by one.
Ma'am,
Yes.
in question number activity 5.9 question number 1,
Wait.
option
Activity
number
5.9, question number 1. Just select. Okay. So what is your doubt?
ma'am, in fourth option,
Hmm.
for any function f
Hmm.
f of f inverse x is equals to x. Ma'am, I think it is wrong
Okay.
because it is f of f inverse x is equal to x for only one function.
Yeah, that's true.
But
So
it is
which are the following option are correct for reversible function f? It is given to us, right?
okay, ma'am, okay.
So 1 is already given to us.
Okay, ma'am, I understood.
Okay.
I'm asking
Got
about
it?
one is
Yeah.
reversible. I
Yeah.
got
So it is given to us that the function is reversible, right? So that means it is given to us the function f is 1. And what is given here, that f composition with f inverse of x is equals to x, right? So this thing will implies that our f is also onto. Okay. So from both of the condition, you can say that your f is invertible, right?
on to
Got it?
1
What?
1 and on 2 both.
Yeah. So 1 is given to us, na, reversible.
Yes, ma'am.
Yeah. And onto we are getting from this expression, right?
Yes, ma'am.
So our function is invertible. Okay.
Okay.
Anyone?
Ma'am, I have a basic algebra doubt. Can I ask?
Am I audible clearly to everyone?
To me, you are.
What about others?
Yes, ma'am. It's clear.
Yeah.
Yes, ma'am, you're on.
So just gather your doubts. So we will discuss all the doubts one by one.
Ma'am,
Just raise your hand or speak. Yes.
yeah, can you write what I'm saying? An expression.
Okay.
4
Hmm?
e
Yes.
e to the power 4x
4x.
is equal to
Yes.
16
16
e to the power x.
e to the power x.
Can I somehow further break this down and try to prove LHS is equals to RHS? Somewhere like, is this the end point?
You want LHS is equals to RHS, something like that.
Yeah, like I just want to know if there is some way to break this down. Maybe I can prove that.
I mean, you can break it down using just, I don't think it won't be simplified anywhere. I'm doing something. E to the power 3x is equals to 4. This is the simplest way of this expression.
Okay, you just subtracted it the other way.
What?
No. Wait, I'm trying to see what you did. You divided 4 on each side and then.
Yeah, and just e to the power minus x. So 4x will become 3x, right?
Okay.
This is the simplest way to do it. If you want to find an x, then you have the way, right?
Oh, okay. Yeah, this is what actually was I was asking.
Okay.
And
So just,
one other
yes.
basic algebra question. This is the gap in knowledge actually.
Okay.
Write 2.
Two.
Another equation I'm saying, just 2.
Okay.
And then start a square root after 2.
Hmm.
And inside the square root, write x as 8x squared
8x squared
plus 9.
plus 9.
If
Okay.
I further want to clean this somehow to bring out x so that I can graph it somehow, is there a possibility to do that? Can I?
You want to bring out x from the out of square root, right?
Kind of. I just want to make this clean so that I can have a better understanding of how the graph would.
For graph, I don't think it was beneficial to go with bring out, because there is only one possibility to bring out x's. Just take common x from both of the terms, so it will become 2x under the root of 8 plus 9x square. But here you get 9 by x square, which is more complicated than this.
Okay, so that's the end of what the equation can be, right?
Yeah, this is the simplest expression.
Also, what did you do on the right side? You multiplied x.
I just what I do, I common this x square. So here is an x square, so it will get out.
Okay,
So
okay,
it's
okay,
become 8 and 9 by
okay.
x, right?
Oh, yeah.
Fine.
Thank you, ma'am. That's all.
What is being discussed? There is nothing. I mean, I'm just discussing your doubts. I don't know what you have guys discussed till yet. Can anyone tell up to which part Arpit discussed with you?
Ma'am,
In the
we
last
discussed almost all the functions, composite, exponential. Actually, examples were left. So sir told us that in the next section, you have to discuss examples.
Okay, so all the theory part is gone, right?
Yes, ma'am.
So you all gone through the videos. Is there any doubts? We can start with first discussing the doubt, and then I will take some examples.
Ma'am, it would be better if you
Do
do
you
the
have
other
any
way
doubt in
around.
theory part? Okay, if
Ma'am,
I do the other
it
way.
would be better it would if you do the other way around. If you take some examples and we work through it and then we see what our doubts are.
Okay, fine.
Better that.
So you have done some of the activity questions, right?
Yes, ma'am.
So if you have any doubt in some question, we can start with discussing that question itself. Okay. Am I clear what I'm saying?
Yes, ma'am.
So if you have doubt in activity question, we first start to discuss, but it is possible that Others haven't gone through it. Okay, fine. We will first discuss some random examples so that your concept get more clear, and then we will start with this. Okay, just wait a second. So consider your fx is equals to 2 by x minus 1. This is the question. And gx is equals to 3 by x. Have you seen this question before?
No, ma'am, not the same example, but type of question.
Okay, fine. So then discuss it. Okay. So you have to find the domain of f, domain of g, and then domain of f composite g, as well as domain of g composite. Okay. So I'll give you 5 minutes. Just try it out, and then we will discuss it. Okay.
Ma'am, it is x minus 1, 2 by.
Yes, it is x minus 1. Okay, so shall we discuss now?
Yes, ma'am.
Okay, so let's come to first fx. Okay, so fx is just 2 upon x minus 1. Whenever our function is rational, some px by qx, then what are the points we should exclude from domain where our qx is equals to 0, right? Our qx should not equals to 0. Those points we have to select, right? So here what is our qx? So qx is x minus 1. So when x minus 1 is equals to 0, so that means x is equals to 1 will imply our qx is equals to 0, right?
Right.
So domain of f is simply or x belongs to real number such that x is not equals to 1. This is clear to everyone?
Or we can write R slash.
Yes, ma'am.
Yeah, that's just a representation, r/1. These all things are equal. Doesn't matter that much. Okay, similar logic will go with gx. Gx is also something like 3 upon x, which is something like px upon qx. So our qx is x. So we don't want our qx should be 0. So when our qx is equals to 0, when x is equals to 0. So in this case, our domain of G is nothing but all the real number except 0, right?
Right.
Okay. So now we go with F composite G. So we want to find domain of F composite G. So for finding domain of F composite G, we always have to remember these two rules. First rule is for all x such that x does not belongs to domain of G, these x should be excluded from the domain of F composite G. This rule is clear to everyone that we don't have to take those x at which G is not defined, because if G is not defined, then how can we define f of G of x, right?
Right.
So, and the second condition is that we have to exclude those x for which G of x does not belongs to domain of f, right? Because if G of x does not belongs to domain of f, means that we cannot define f of G of x. We cannot say what is f of G of x means, right? So that's why we have to exclude all those x for which G of x does not belongs to domain of f, right? This is clear to everyone?
Ma'am.
Ma'am, can you please explain first one?
Okay. So in first one, what we want to find? We want to find domain of F composite G, right? So we want to find all those x belongs to real number such that we can define f of G of x, right? So in this chain, first we have to define G of x, right? So G of x will define only when x belongs to domain of G, right? The statement is clear?
Yes, ma'am.
Right.
Which in the previous case, if you take this current case that we are solving, it would be R minus 0.
Yeah. So at 0, G of x is not defined. So G of x, so that means 0 cannot be belong to domain of F composite G. That we can get from the first point.
Right.
Right. So this statement is clear, right? That all x, we should exclude all those x for which G of x is not defined, because we want to find the domain of F composite G, right? So we want to find all those x belongs to real number for which our f of G of x is well defined. But what if in this chain G of x is not itself well defined? So what can we say about f of G of x, right? So first we want our x should belongs to domain of G. This fact is clear to everyone? Now second thing, we want to define f of G of x. So that means this G of x should belongs to domain of f. Otherwise, we cannot define G of x, f of G of x, right? Because if something is not in the function domain, it is not defined, right? This thing you know, right?
Yeah, x should belong to the domain.
And
It is
second
clear?
point, ma'am, and second point, what is the meaning of GX should not belong to domain of F?
In second point, I am saying that we should exclude all those x for which G of x does not belongs to domain of f. because then f of g of x is not defined, because we cannot define the f of something which is not in domain, right? This is clear?
So that means
So
only zero
F
should be excluded.
f of g
Yeah.
is different from f.
Correct.
F of gx is different from f.
Yes, f of gx is different from x because we want to, first of all, we
Then
want to
what-
find the domain of f composite g. That means we want to find all x belongs to real number for which f of g of x should be well defined, right? So now if you suppose x does not belongs to domain of g and represented by dg, dg is domain of g. Suppose x does not belongs to domain of g, then we cannot say anything about g of x, right? Is not defined.
Yes, ma'am. Right. This part is clear.
Does
Now
not
suppose we take x belongs to real number such that g of x does not belongs to domain of f. Then f of g of x is not defined, right? Suppose this g of x some t, then you cannot define f of t if t does not belongs to domain of f, right?
Ma'am, can we walk through an example?
Ma'am,
Because
Yeah,
this
yeah,
not
yeah.
belongs to
Gx
is very
different
confusing.
from f, ma'am.
Yeah, okay, fine. So just go back to our previous example. So f of x is 2 upon x minus 1 and g of x is, I guess, 3 upon x or something. Yeah,
Right, ma'am.
Yes, ma'am.
3 upon x. Okay. So here we get that domain of f is all real number excluded with 0.1. Here domain of g is all real number excluded with 0.0.
Yeah.
Now we want to find domain of f composite g. So at which x belongs to real number, our gx is not defined.
First we write f
At
of g
zero.
first.
At
Right?
zero.
At 0, right? So that means this will implies that 0 does not belongs to domain of f composite g. Now
Yes,
this is clear?
yes, ma'am.
Okay. Now what are the points where f is not defined? So we know that x is equals to 1, fx is not defined,
Yes, ma'am.
right? So what is our task? So our task is to find such x. Our task is to find x such that g of x is equals to 1. This is our task now. So what will be? So that means we want 3 upon x to be 1. So that means we want x to be 3. So now here we get, if you put x is equals to 3, right? So here, if we put
Yes, ma'am.
x is equals to 3, our g of x will be 1, right? But
Yes,
then
ma'am.
if you want to find f of g of x, what you have to find? You have to find f of 1. And we know that f of 1 is not defined. Okay.
Okay,
So
ma'am.
that means 3 also not belongs to domain of f composite G. Correct?
Yes, ma'am.
So that means we are
Ma'am, we
excluding
can
2 points.
also do this now by first finding out f of g and then see from there.
Yeah, but there is a problem. That's why I'm taking this example. Okay. So,
What is the problem in this? First find f of g, then
okay. Suppose f of g of x. Okay. So what we have to find? First of all, that means we are doing 2 x. In place of x, we have to put g of x minus 1, right? So it is 2 upon 3 upon x minus 1. So what it would be? It would be 2x upon 3 minus x, right?
Yes, yes, yes.
So from the above discussion, forget about how f composite G look like. From the above discussion, what we know that domain of f composite G possibly we don't know exactly, but possibly it is real number minus with 0 and 3, right? From the above discussion, we know this,
Yes,
right? So, but what is your f composite G look like? So your f composite G is look like 2x upon x minus 3, right?
ma'am.
In this expression, if you put 0, in this expression, if you
Ma'am,
put 0,
we have removed 0 by first condition of that.
yeah, right. So that's why we just cannot go through the what f composite G look like, because here it seems to be at 0, this function is defined, right? it seems to be it is defined at 0, because if I consider h of x is equals to 2x upon x minus 3 and if I want to and if I will tell you that find the domain of h, what will you say? That all real number excluding with plus 3, right? Right
Yes,
or
ma'am.
not? Right?
Yes, ma'am.
Right. So this function is defined at 0,
I am
but
telling
this
you.
f composite g is not defined at x is equals to 0.
Yes, ma'am. That's right. Ma'am, I am
Yeah.
telling in place of second condition that we are writing in domain of f, we can use that f of g of x is equals to 2x upon x minus 3, and from there also we can get
Okay,
that
okay.
not
Okay, okay. So from here also you can take that at x is equals to 3, it is not defined, right?
Yes, ma'am. And from first condition we can get that 0
Yeah,
is also
from the first condition we can get those things. From the second condition we can get this thing. This is another way, but sometimes it may happen that this condition will also give some extra points where our function is not defined, but still f composite g will be defined. So that's why I'm saying that whenever you have to find the domain of f composite g, just don't go through the expression itself. There are some points where g is not defined, right? There are some points where g is not defined, but the expression will make sense. Okay.
Okay. Okay.
So first go with domain of g. So first go to the domain of g and then go to the domain of f composite g. Then you can use this expression. But first point you should note that you have to consider what is the domain of g and at what points it is not defined. Okay.
So, ma'am, in this case, it would come out that the domain of f of g is r minus 0,3.
Yeah. In this case, it come out to be that it is exactly equals to r minus 0,3.
Okay.
And even though it is always exactly equals to r minus 0,3 if you follow these two rules.
Right.
Okay. So what we'll get domain of f is r minus singleton 1. Domain of g is r minus singleton 0. Domain of f composite g is r minus 0 and 3. Now, what about g composite f? G composite f. So what you can say g composite f? So it is 3 upon what is our f? So our f is 2 upon x minus 1, right? Correct? So it is 3 by 2 of x minus 1. This is your g composite f. This is expression. It's just an expression. Don't go for domain with the help of this expression. First, consider what is the domain of f. Okay. So our domain of f is that all real number excluded with plus 1. Right? So this will imply this 1 does not belongs to domain of g composite f. Correct?
Yes, ma'am.
Am I right?
Yes,
right
ma'am.
now?
Yes, ma'am. Yes.
So now what is the second thing? I want to find those points. I want to find those points at which g of x is not defined. So g of x is our 3 by x. 3 by x. So I want all those x belongs, I don't want all those x belongs to real number for which f of x is equals to 0. But as you can see that our f of x is just nothing but 2 upon x minus 1. So it cannot be equals to 0 at any point. Right? So we can take all the real numbers. So that means there does not exist any such x such that f of x is equals to 0. Right? Because if the only possibility to make this expression is 0, to take x to be infinity or to take x tends to be infinity, right? Otherwise it won't be 0. So that means there does not exist any real number for which this expression is 0. Okay.
Yes, ma'am.
So ultimately the answer is r minus 1. That's it.
Yeah, r minus 1. But you observe that this expression is also holds for x is equals to 1, right?
This expression holds for x equals to 1, yes.
Yeah, but that 1 does not belongs to domain of g composite. That's my point of taking this example, is that you don't have to go through the expression itself. You should consider what is the domain of inside function f, or what is the domain of g
We can
composite of
directly
e.
find. We can directly
Yeah.
find. Thank
Yeah.
you.
So this is one example.
Why 0 is not included?
No, 0 is included in g composite f, na?
Yes, ma'am.
Domain of G composite S is just R minus singleton 1. 0 is included.
Yeah, sorry. Why 0 is included?
Because if you consider at x is equals to 0, what is the value of f of x? So f of x is nothing but 2 upon 0 minus 1, which is minus 2, right? And this minus 2 belongs to domain of G, right?
Yes, ma'am.
So you can say what is G of minus 2. This is well defined. So that's why G composite f of 0 is well defined. Correct?
Yes, ma'am.
Got it?
Yes, ma'am.
Any confusion?
No, ma'am.
Okay, fine. Good. So that's why I'm saying you have to consider domain of both of the functions, that what point you should exclude and what point you should take. Okay. This is example. Now go to next thing. So if I will, you know how the graph of an exponential function look like, right? You have
Yes.
learned those things?
Yes, ma'am.
Okay, so if I will say that graph this function 3 to the power minus x plus 2, can you guys do it?
Yes, ma'am.
So just try for 2 minutes, then I will explain. Okay, so anyone want to explain again? Okay, fine. Other one can try this, try to plot this graph, then I will discuss it. Okay. So here, what is our main task? So our question is that we have to find domain of G composite F, right? Okay. So by the first rule, what we want to exclude all those x for which f is not defined, right? What is our f of x? So our f of x is 2 upon x minus 1. So we know that x is equals to 1, fx is not defined.
Yes.
So this will implies at x is equals to 1, x is equals to 1 does not belongs to domain of f composite G. This fact is clear too? This fact is clear? Karishma, is it clear? Yes,
No,
okay.
it should be GOF.
Okay, now go to second thing. So what the second thing says? That I want to exclude all those x for which g of f of x is not defined.
For the earlier one, shouldn't it be G of F? I mean, x is equal to 1 not belonging to. That is the question, isn't it?
Oh, sorry. I have.
Okay.
Fine. Thank you.
Thank you.
This is G composite. Okay, fine. So now next step is that we want to find all those x for which g of f of x is not defined. So that means I want to find all those x for which this does not belongs to domain of G. So what are the point which does not belongs to domain of G? So x is equals to 0 does not belongs to domain of G, right? So I want to find the value of x for which f of x is equals to 0. Okay, because x is equals to 0 does not belongs to G. So that means at some x, f of x is equals to 0, this does not belongs to G. So when f of x is equals to 0, so that means I want 2 upon x minus 1 is equals to 0. But this is not possible at any point. It cannot be equals to 0, right? Karishma, it is okay till now? Okay, so that means our f of x, that means we don't have to exclude any other points also. So that means the only point we have to exclude from domain of G composite F is 1. Okay, so this will implies domain of G composite F is nothing but real number minus with 1. Now it is okay? Okay, fine. Other one, please try this question. 3 to the power minus x plus 2. Rules for what? Graphing the function or something else?
Ma'am, for domain of G of F or F of G.
Okay. This one may try this question. So these are the just only 2 rules you should follow first. Okay, now it is clear?
Yes, ma'am.
Okay, thank you. And also see what are the y-intercepts, what are the end behavior of this function. Okay, what are the x-intercepts? All other properties which till now we have discussed. What are the roots? There exist any roots or not? Think about this for 2 minutes, then we will discuss it. Yes, Fatima, we'll discuss all the practice assignment doubts also after this question. 3 to the power minus x plus 2. This expression is itself simplified. You cannot simplify this expression more, because you can simplify expression if it is something p by q, or there is some common factor to delete. It is itself a simplest form. Yeah, negative x is there, but don't worry about it. You know how to deal with negative x. Okay, fine. So you can simplify it in this way, that it is 1 by 3 of x plus 2. If you want positive x, then only. This thing you can do.
Draw the graph.
Okay, yeah. Just a minute. Okay, so shall we discuss, or anyone want any time? I can give 5 minutes more. Someone wants.
We can discuss more.
Okay. So before this question, I am just tell you some scaling of graphs, that how you should scale it or shifting. Okay. So this is some shifting of graphs. You probably know, so I'm refreshing it. Okay, suppose you have the start with simple thing. Suppose you have line y is equals to x, right? Okay, so if I'll take this, so you know the line, the graph of line look like this. This is y is equals to x. Okay. This will work. Same in both variables. Suppose you have some random function y is equals to f of x, and this is your graph. Okay. Okay. So now suppose you have to plot, you know this graph, and I say that you have to plot y is equals to f of x plus c. So here what we are doing, we are adding some units in y, right? We are adding something in y. So what happened? This graph will shift upwards c units. So that means, suppose this is -1, then it will shift to -1 plus c. Whatever c would be. If c is negative, it will go downwards, or c is positive, it will go upward. Okay. So that means if someone told that you are given the graph of y is equals to fx, and you have to draw the graph of y is equals to fx plus c, note that here we are adding the constant in y, not in anywhere else. Okay. So then what will happen? Our graph will shift c units upward. So then our graph will something look like similar to this, but note that this point is now -1 plus. Similar to this, but just shift it one unit upward. Okay. Now, if someone tell that you have to plot the graph of y is equals to f of x minus c. Okay, fine. Here we are taking c is positive. Okay, so if someone says you have to draw the graph of f of x minus c, then what you will do? You will shift this graph downward c units. So then this will be the graph of f of x minus c. Now this point is your minus x minus c. This is c unit downwards. These two things is clear to everyone? How you can shift graph if there is some constant addition of in the y coordinate?
Yes.
Okay. Now suppose I am adding something in x, that is I am doing x plus c. So then what will happen? Your graph will shift c units left. C units left. So that means it will shift something here. So it will shift something like here. And this point, if suppose this point is your -1 and this point is your 1, then it will shift C unit left. So that means -1 minus. This fact is clear?
No.
Okay, just I'll go with an example. So suppose you have this graph y is equals to x square, right? So you know what? This is a parabola, right? Upward parabola. So it will look like this. This is suppose this is nicely drawn. So
Okay.
then if you have to plot y is equals to x plus c the whole square, or x plus 2 the whole square, what will happen? Your graph will shift this way. I will just tell you in graph. Okay.
Oh, x plus 2 actually it increases the value of x, isn't it? So doesn't it move right?
No, actually, that's the catch. When you add C in X variable, it will go to the left side.
That is, I mean, that's what I'm not getting.
1 minute, I will tell you with precise graph.
Okay.
Now you guys are able to see this screen,
Yes, ma'am.
right?
Yeah.
So
Yeah.
here, this red one is a graph of y is equals to x square, right? And I am adding 2 units in x coordinate. So the graph is shifting to the left, right? Getting?
Yeah.
If I
I can see
suppose
that.
it to be 5, it will shift more to the left.
Well, why is that? I mean, why is it happening?
Actually, what happened now when x is equals to minus, I mean, you just compute this value in some terms. I mean, at x is equals to 0, this is giving 0. But when x is equals to 0, this y is equals to become a 5 square, that is 25, right? So
Okay.
25 will come some up here, right? So
Okay.
this distance is traveled by a graph now.
Oh,
5 units left.
okay.
Okay,
So,
got it?
so the peak, I mean, the peak or what do you call that? What do you call that? Peak?
Vertex.
Vertex. Okay.
Y in
Vertex
Yeah. So
value changes. Oh,
yeah. So that's what I'm saying. And this will happen in general any graph. If you consider y is equals to fx, this scaling will always help you to draw the graph. That's why I'm telling this thing. Suppose now uh if I'll add in x in y coordinate something, that why I'm saying that it moves upward and downward.
okay.
So suppose I will add 3 units. So then you
Yeah.
observe this is our original graph
Yeah. This is
F1
very
and
clear.
3 units upward, correct?
Yeah. Yeah.
So everyone is clear with
Straightforward.
this thing?
Ma'am,
Yes.
ma'am, without, so what will be the, like, whatever the value of x is, if we are adding some constant, then it will shift towards the left.
Yes, it will shift toward the left.
If the c is positive,
Uh,
yes.
or
If C is
yeah, I
negative,
mean, if
then it
C is
will move right.
positive, correct. C
Yes.
is positive, then
understand.
only. Suppose if I'll do something y is equals to x, I mean, if
Minus
I'll
five.
take x minus 5,
Mm.
then you observe that it will go to the right side,
Square. Okay.
right? So that's why I mean, I'm taking the scalar to be positive, and then only I'm saying that it will shift left, right, or somewhere. Okay.
So it's always the opposite. Like,
Yeah, it's always the opposite.
okay.
Got it? Everyone?
Yeah. I mean, now, I mean, this is like a
Now
rule
we
to
are
us.
looking where the origin is moving. For x is equals to 5, y is becoming 0 in the fourth graph. For
Which color? This blue
with
one?
purple one. For
Yeah.
x
So
for x equal to 5, it is y is becoming 0. So it is moving towards the right. We can understand
yeah.
like this.
You can yeah, but this is simple graph now. You can easily tell that where it goes. But suppose you have some complicated expression, then you cannot say anything, right?
Okay.
Yes.
Yeah.
That's why I'm telling this rule. If you have, I'm just explicitly write it. Now it is clear, right? How it moves.
Yeah, it is clear, and it is always the value that we add additionally. That
Yeah.
much it moves.
Yeah, that much, that unit it will move. Okay.
Okay.
So shifting. So
Because
let us
because
suppose
that
y
is
is
how
equals,
that is where Y moves to 0, right? You have to think from that perspective. So whoever suggested earlier, he was right.
okay.
So the function value has to become 0, and that's where you
Yeah,
see.
that's where the vertex will be gone.
Right.
But everyone is clear with the shifting, right? So the graph of y is equals to fx plus c will shift c units upward. And the graph of y is equals to f of x minus c will shift c units downward, right? And the graph of y is equals to f of x plus c. Now I'm adding in x coordinate. So the shift will be c units left. So that means here. And the graph of y is equals to f of x minus c will shift c units right. Here. Is this correct? This is clear to everyone? Okay.
Yes, ma'am, it's clear.
So our task is to graph f of x is equals to 3 to the power minus x plus 2, right? Now from the above discussion, it is clear if I will find the graph of 3 to the power minus x, then I just have to shift it 2 units upward and I will get this graph, right?
Yes, ma'am.
Okay. So you are now suppose our consider gx is equals to 3 to the power minus x, but this
3
is same
units.
as 1 by 3 to the power x.
We have to move
Right.
3 units, right? Because if
So
x
it is
is
an
0.
exponential function.
Sorry, ma'am.
If x is 0, then it will be plus 1. No, I'm telling if I am drawing this graph 3 to the power minus x, it will itself will cut at 1, right? So then 2 units upward will become 3. So we don't have to bother about
Right.
whatever x values is or z value is, right? So just
Okay.
draw the graph and just shift it 1 unit, 2 units or whatever c units it's given to us, correct? So now, if you consider 3 to the power minus x, so it is nothing but 1 by 3 to the power x. So it is an exponential function of a to the power x type, where our a is lies between 0 to 1, right? So you
Yes,
know
ma'am.
how the graph will look like. Anyone
Yes,
could tell?
ma'am. Yes,
It is
ma'am.
in. Okay. So
It will decreasing and going from positive towards yes.
it will be decreasing. And what is the y-intercept? Y-intercept is
0,3.
Yeah, so y-intercept, how do you calculate y-intercept? So just put x is equals to 0. So when x is equals to 0, g of 0 is 1 by 3 to the power 0, which is 1. So this is your y-intercept. This is 1 comma 0, right?
But 2 unit we
Yeah, I'm doing 2 unit. So this is the graph of 3 to the power minus x. This much is clear to everyone?
Ma'am,
Yes.
ma'am, why it is y-intercept is 1, it should be 3 now.
3 to the power 0. X, if we are putting x is
What is
equals to 0,
3 raised to
what
the
is
power
the
minus
y-intercept?
Ma'am, when x value is 0 and what
Yeah.
then what?
Yeah, I'm not telling the y-intercept of this graph. I'm just taking this y-intercept. If you consider g of x is equals to 3 to the power minus x, then the y-intercept of this graph is 1. That's I'm telling. Because no, the catch is here that you don't have to bother about this plus 2. That's I'm telling. You don't have to bother about this plus 2. We will make it just shifting it 2 units upward. This will gives us our all the required properties, whatever we want. We just want to draw the graph of this exponential function. Okay.
Ma'am,
Yes.
sorry, go ahead. Go ahead.
Yeah. Okay.
Ma'am,
So this is a graph of yes.
So whatever the value like function will be given to us, we have to always look at x term and calculate the y-intercept, irrespective of what is being added or subtracted.
No. I'm not telling about what is the y-intercept of fx. The y-intercept of fx is obviously 3 because if you put x is equals to 0, this will become 3. I'm just telling that if I want to draw the graph of 3 to the power minus x, it will intersect at this point 1 comma 0. That much you have agreed?
Yes, ma'am. Yes, ma'am.
Okay. So now what
Ma'am,
we'll do?
one question, ma'am. On
Yes,
the right
yes.
side, you have written a is between 0 and 1. A
Yes.
should be greater than 0. That's it.
So that's the meaning of this expression, na? A is greater than 0 and less than 1.
Why less than 1 is what I'm asking.
No. I'm in particularly telling that this is 1 by 3, right? So 1 by 3 is strictly less than 1.
Oh, okay.
So
Yeah,
you have
yeah,
learned
yeah.
two graph now, a to the power x when
Right.
a is between 0 to 1. Sorry, just strictly less than 0 to 1, and when a is greater than 1, right? So I'm just telling here
Mm-hmm.
a is
Right.
1 by
Right.
3. So our a
In this
will lie
scenario
between
for
0 to
quadratic.
1.
Yeah, agree.
Yeah. So that's why our graph will become decreasing. Otherwise, it will increase, right?
Right.
So now what we have to do, we have to shift our graph 2 units upward. So if I will go 2 units upward from this point, what will be the point? Point will be 3, 0, right? Because this is 1 unit length, and I'm adding 2 units also. So it will become 3, 0. So what we will do, so we'll just take this graph and shift it upwards.
It should be 0, 3 and 0, 1.
What? Sorry.
Ma'am, it should be 0, 1 and 0, 3 now.
Oh, sorry. That's y-intercept. Yeah. 0, 1 and 0, 3. But you are getting what is my point, right?
Yes, ma'am.
Okay, so this is a graph of your function. Now I'll draw it neat and clear. This is a point 0, 3 because x coordinate is 0. Okay, and this is a graph of f of x is equals to 3 to the power minus x plus 2. This much you everyone is agree? Any doubt? No? Okay, fine.
No doubt.
So now
Yeah.
we'll go to y-intercept. Yes?
Now you're given 4 factors: y-intercept, n behavior, and x.
Yeah. So this graph will tell you everything, but I will recall once again. So y-intercept is 3 clearly, right? Now, what is the end behavior? Limit x goes to infinity. What will be fx?
Tends to 0.
No,
No.
it won't end to
2.
0 because
Ma'am,
here
2.
you have assumpted. Yes,
2. It tends to 2.
it will tends to 3, right?
2 or 3?
Oh, yeah, 1 unit downwards, so 2.
Yeah.
And as limit x goes to minus infinity, f of x will increase, so it will goes to plus infinity, right?
Okay.
So this thing is clear? There's 1 unit gap.
Yeah.
Okay, ma'am. So if it was only 3 to the power of minus x, then it will be tends to 0.
Yeah, if it is 3 to the power minus x, it will tend to 0. But if it is 3 to the power minus x plus 2, it will tend to 2.
Yes, ma'am.
Okay, fine. And what else we can discuss in this graph? So it is increasing or decreasing? It is decreasing, right?
Yes, ma'am.
Ma'am, so
Yes.
the x value could be any number, right? So on the x axis
Yeah,
we have it any real number.
yeah, x
Now
could be any real number.
y value would be at max 3.
Y value could be at max 3. That's the meaning of limit x goes to infinity and minus. What is the at most value? So it is 2, right?
y2
No.
it would go maximum till 3, na?
No.
If x is 0, if
Oh,
x
no.
is
It is
0,
not maximum value. It is minimum value.
yeah, minimum
Because it
value is
cannot
2.
go.
Minimum value
Yeah.
is 2, yes.
Yeah.
Minimum value is 2.
Maximum, obviously, it is going to infinity. So it can go anywhere. It doesn't matter. 3, 4. Fine.
How it can go to infinity? It can only range 3 to the power of
No.
minus x, can range between 0 and 1, right?
3 to the power minus x will range between anything, na? I mean, x, you don't have a limitation on x. That's why I'm saying, na, here we get limit x goes to minus infinity of f of x is equals to infinity. This thing is clear to you?
No, let us just talk one part of it, right? For f of
Okay.
x to equals to 3 to the power of minus x.
Okay.
It is 1 by 3 whole to the power of x, right?
Yeah, 1 by 3 to the power x. But this exponential is defined for all real number, right?
Right. Now,
So
as x increases,
as
the
x
value of
increases,
1,
it will goes to 2. But what if x decreases? What if x goes to minus infinity? This is also possible now. You can take minus 1000 here also. The function is still defined, right?
So if it is minus,
so then minus minus will become plus, and it will become 3 to the power 1000 plus 2. That is a huge number, right?
okay. Hmm.
Ma'am, I
So
have a
this,
doubt.
yes.
Ma'am, how you concluded that the minimum value will be 2?
No, you don't have to bother about it. You will discuss minimum, maximum, all values in week 7. So just he asked about some maximum value and minimum value. That's why I'm telling. You will discuss it on week 7 in detail. Okay. So
Okay, ma'am.
that's fine. So this thing is clear to you. So graph, you know how to draw, right? If I'll give any exponential graph, you are able to handle it little bit, right? If you give simple graph, f of x is equals to
Yeah, we
some
understood this.
100 x plus 100, right? So you can able to draw this graph, right?
Yeah.
Okay. So till now it is okay. Now someone has doubt in practice assignment.
No, the roots you left the last part.
Yeah, there is no root, right? Because it is not touching x-axis, so no roots.
Oh, so we will be able to find the roots only by looking at the graph.
Yeah, we can able to find the roots only by looking at them.
Okay.
Because obviously it is not going below 2. So how could it reach to 0? It cannot,
Okay.
right?
This I understood. But
Okay.
if it is some other equation and if you have to find the roots, is there any specific method to find out?
Yeah. Then you have problems. So that's why most of the, this graphical method is mainly used for determining the roots.
Okay.
So there are some problems where you have given some fx which is a little bit complicated, and it is equals to some constant. So what you have to do, you just have to draw the graph of f of x minus c and find and look at the graph where it intersect to the x-axis. If not, then there is no roots, right?
Okay. Okay.
Is it not that exponential graphs do not have x-intercept?
Sorry, exponential graph.
Do not have roots?
No, it is possible that exponential graph may have roots. For example, if I'll suppose the same function 3 to the power minus, but in place of plus 2, if I'll put minus 2, then what will happen? We have to lift our graph, lift our graph 2 units downward. Then it will cut x-axis, right? So it can have roots.
Okay, ma'am.
Okay. So it is not in general true. If it is purely exponential, that is, if it is something a to the power x, then it won't have roots, right?
Yes, ma'am.
But if some constant or some other function is involved, then we cannot say anything about it.
Ma'am,
Okay.
ma'am, when x is minus infinity, it will become 0.
When x is minus infinity,
No, it will
won't
become
become
a very
0.
large number.
Why?
No, no, no.
Because
See,
3 to the power minus, okay, minus infinity. I don't want to write this, but okay, fine.
no, ma'am,
Yes.
it's not of. Hello, am I
Yes,
audible?
yes. Yeah.
Ma'am, in the previous example, you had taken a power x.
Yeah.
Um, in place of x, if we put minus infinity, then it becomes 1 by a power infinity, which is like a 1 by infinity, which is
Yeah. In case
tending
of
to
a to the
0.
power x, there is different thing. Now I'm taking a to be, a is between 0 to 1. Then this a to the power x,
Mhm.
you learn this thing in theory part, right? This goes to infinity, right? You learn the behavior of a to the power x explicitly or not? I can recall if you want.
Oh, we are taking only positives.
Sorry.
It will
What do
help
you
if
mean?
you can recall.
Okay, fine. So there are major two cases when your zero is less than 1. Okay. So in our course, we don't say that it is exponential function, so a is not equals to 1. We are defining in this way, right? Our a is not equals to 1. It can be defined, but it will ultimately become a constant function, so don't need to be discussed in detail. strictly greater than. Okay, so in this case, what will happen? Limit x goes to infinity, a to the power x. This will goes to 0, right? And limit x goes to minus infinity, a to the power x. This will go to plus infinity. Just listen what I'm saying. Then I'll discuss it with the help of graph. That will be beneficial. A to the power x, this goes to plus infinity. And whenever your limit x goes to minus infinity, a to the power x, this will go to 0. Okay. Since our a is between 0 to 1, you know the graph will look like decreasing, something like that, right? And in this case, your graph will look like increasing. The graph is clear to everyone? That the graph will look like this? No?
Um,
Am I
just
audible?
give us, yes, ma'am. Just give us 1 second to absorb this one, right? So if A is
Okay.
greater than this one, as X
You just
goes
observe
to
till now the graph.
X will go to
I'm just
infinity.
telling about, I'm just asking about
Yes,
graph.
yes, ma'am. So as X goes to infinity, A to the power X goes to 0. So it is coming down, which is a decreasing function.
0.
Right.
If a is
And
between 0 to 1,
right,
then
right. Or else as A is greater than 1, it will go to the
now,
positive side. It's an increasing function. Okay. Got it, ma'am.
yeah. So you can observe this with the help of example. Suppose I will take a to be 1 by 2, right? So then what will happen? If I'll put a to the power 2, so what is this? This is 1 by 2 to the power 2. So what will become 1 by 4, right? And we know that 1 by 4 is less than 1 by 2, right?
Right, right.
Correct. Similarly, if I'll take a to the power 4, it will become 1 by 16, which is again less than 1 by 4, which is less than 1 by 2, right? So as you observe, whenever I am increasing the value of x, our function is keep decreasing, right? But we
Right.
know at any point it cannot reach to be 0 because a to the power x is equals to 0. This cannot happen
Right.
for any x.
It
Correct?
can maximum reach 1.
Yeah, it can. No. What? It can be as small as it want, but it cannot be equals to 0. That's why I'm saying.
It can
And
be
it
maximum 1, right? Meaning
no.
if
If
A becomes
wait.
if X becomes 0, this will become 1. That's the maximum
Yeah.
value it can reach, right?
No, wait. That's where you are misleading because we are taking x belongs to real number. Our real number has minus also, right? So you can take a to the power minus 2. So if I'll take 1 by 2 to the power
Actually,
minus 2, this will
yeah, yeah.
become 2 square, which will become 4, which is greater than 1 by 2, right? So that
Mm,
means in this direction it is increasing and in this direction it is decreasing, correct?
right, right.
So this is the behavior of graph of a to the power x when our a is between 0 to 1. This thing is clear to everyone? Any doubt?
Yes, no doubt.
Okay, fine. So from the graph, you can observe that if you,
Sorry to interrupt.
yeah.
You're speaking about some value of 1. I mean, I didn't really get that. What was that?
Okay,
F
what
of,
he was saying that if you take 1 by 2 to the power 0, then it is equals to 1, correct?
yeah.
So he is not considering x to be negative.
Okay.
That's what his problem. He thought
Yeah.
if we cannot go in the left side of the 0, we cannot take -1, -2, and so on. But we can
We
because
can, but what happens when it is 0? The value will be 1.
yeah,
So
because 1
no,
by 2 to the power 0 is equals to
what I was saying
this
was I was thinking that the maximum value 1 by 2 can reach is 1,
is 1, but this
which
is
is
not
incorrect,
possible.
right?
Yeah,
Which is
that's
incorrect
it.
because it can reach 1 when X becomes 0, but when
Yeah.
X becomes negative, it starts increasing.
Yeah. So
Okay.
you know this property that a to the power 0 is equals to 1 for all a belongs to real number except 0 because 0 to the power 0 is undefined.
Okay. And this is nothing but the y-intercept.
Yeah, this is nothing but the y-intercept, correct.
Okay.
1,
Okay.
0, 1.
Yeah. Okay.
So this fact is clear to everyone?
And similarly, you mentioned about the example 3 power minus x minus 2. For that, we
Yeah.
will have roots. Can you just say that? I mean, can you just demonstrate that?
For 3 to the power minus x plus 2, what will happen? Your x-intercept will be
Will go up.
to you. Yeah, it will go up.
So no
So our
roots. That's
x-intercept,
clear.
Yeah. So it is just 3 to the power 0 plus 2. So it is 1 plus 2. So it is 3, right? So this will be
Okay.
the y-intercept of this graph.
No. I want to know the roots when the case is 3 power minus x minus 2.
Oh, minus 2. In minus 2, it will go downwards 2
Yeah,
units.
downward, and we will have roots. How will we find that root?
We have roots, right? Okay.
Yeah.
So those roots you can find, you know what is the logarithmic function? Anyone?
Oh, so you'll be applying log rule. Okay.
Yeah. So that's
That's the
why.
opposite of exponents.
Yeah. So that I think you will learn in next
Next
week.
chapter. Next
Yeah.
next week. Okay. All right.
So the concept of log will come from the exponential that you want reversible functions all most of the cases. So what we will do, so we just try to find what is the reversible function for exponential, and that will lead to log function. Okay.
Okay.
So
Okay.
that you will learn in next week mostly.
Okay.
Fine. So this case is
Ma'am,
clear to everyone. I will go to positive
ma'am,
case.
I have
I
a
mean
doubt.
greater strictly. Yes.
Ma'am, when you define a power x as a function f of x, then
Yeah.
how can we um, say about the value of the function when x is irrational?
Yeah, we can say that
We are defining a
that's.
domain as a real number, right? Then we have to
But
define
real
the
number
value
will
of the
contain
function for
irrational number,
irrational.
na?
Yeah, it will contain irrational number. Then how to define the value of the function when x is irrational?
Okay, so what happened? You want to define a to the power q, where q is your irrational number, right? That's why you're saying,
Yeah,
right?
yeah.
In the first week, you have learned if you have an irrational number, then you can find a sequence. Suppose you can find a sequence from rational number which will converge to it, right? You know this fact that if q
Ma-
is an irrational number, then there exists some p1, p2, p3, and so on, and this which will converges to q. This is a fact from the first week 1,
Ma'am,
right?
just a second. What is this P1, P2, P3?
These are the rational numbers. So
Okay.
if you have an irrational number, you can find a sequence P1, P2, P3, and so on
Mhm.
belongs to rational number, which will converge to Q. I mean, this will help to define what is the irrational number or what is a to the power q. So then what will happen whenever you have this sequence, then a to the power p1, you know how to define rational numbers a to the power x, right?
Rational numbers. Yeah, yeah.
So then what happened? This sequence will go to a to the power q. So that's how you define the irrational power of exponent.
Ma'am, I
I
didn't
think
understand this part.
okay, fine, don't worry. So first fact, what I'm saying
That
that
series
if
I
you have,
didn't
suppose you
understand.
have root 2, okay,
Yeah,
you
yeah,
know root 2 is irrational, correct?
yeah, yeah.
So what happened for root 2, we can find a sequence, for example 1.41, then 1.414 or something like that. Okay, I don't know exactly what is 1.41 or so. Something p1 belongs to rationals, p2 belongs to rationals, and so on, such that this p1, p2, p3, and so on will go to root 2. This fact you
So
know?
that means P1, P2, and all are equivalent.
No, wait, not equivalent.
But previously, like, ma'am, you
Wait,
have
wait.
taken 1.41,
Yeah, so because
1.412.
I don't know
They're
the what is the
nearly
sequence.
equal, right?
Suppose if I'll take 1.41 to be my P1, if I'll take 1.414 to be my P2,
Mhm.
and 1.4141, this will be P3, and
Mhm.
1.4141, and so on, right? So what happened? This sequence will lead to my root 2. I think this you have discussed in this week also.
Yeah, yeah. Oh, okay, got it.
Yeah. So that's
Oh,
how you will
okay.
define the a to the power x when x belongs to irrational numbers. I think
Okay.
you will recall in first I think first lecture of this week we also discussed this. I mean, sir have discussed it, that how could you define the power of some number, or the power is irrational. Then you can follow up the sequence and you will get your things. Okay.
Okay. Then what to do with the sequence?
Yeah, just take a to the power. Then you know how to define a to the power p1, a to the power p2, a to the power p3. So then this sequence will go to a to the power q, or a to the power root 2 in this case.
Okay.
Okay, correct?
Okay. Then
Fine.
what? How to do with function, ma'am?
No, how to deal with function? And
Yeah.
that's how we define for a to the power x. No, wait, what happened here? You know, for any number a, you know how to define a to the power n when x belongs to rationals, right?
Yeah.
Just answer my questions. Okay, so you know this thing, that how to define if your x belongs to rationals. Okay,
Yeah.
now what will happen if I'll take root 2, which is an irrational number? So you know there exists some sequence, p1 belongs to q, p2 belongs to q, and so on, which will
That it
reach
tends
to
to
q
Q.
at infinity, right?
Yeah.
Okay, so then what will happen? What is our goal? Our goal is to define a to the power x when x belongs to irrational, right?
Yeah.
So what I am going to say, that we will define a to the power root 2 to be the limit of this sequence, a to the power p1, a to the power p2, and so on. This sequence will go to root 2, and we are defining that thing to be a to the power root. Okay. So this fact is just telling you that we can define a to the power x for all x belongs to real numbers. Correct? Now it is clear. You
Yeah.
don't have to bother about how does this look. I mean, you don't know how it looks, right? You know a square will look some a into a. You know a to the power 1 by 2 will look a root 2 or something like that, right? But you don't know how a to the power irrational number looks. So you don't have to bother about how it looks, because it doesn't matter. It will come out to be a sequence, but that calculation will reduced in some sense. Okay. You just have to know that it is well defined, and it is well defined in this sequential sense. Correct?
Yeah. Yeah.
Yeah, it is clear or not? I can explain one more time. It's okay.
Yeah, ma'am. It's clear. Thanks.
Right? So get back to our graph. So these two graphs are clear, or should I explain more? Anyone? It is clear?
Yes, ma'am, clear, but only limit part is not clear.
Okay, limit part is not clear. Okay, so in this case, you observe when we go to plus infinity, our graph is approaching towards zero, closer and closer and closer, right?
Yes, ma'am.
So as x goes to plus infinity, our graph will go to zero. So that's why the limit is zero, correct? And when we go to minus infinity, you observe that our graph is increasing towards upwards. So that means it is somehow reaching plus infinity. So that's why when x goes to minus infinity, our limit is plus infinity. This fact is clear to you?
Yes, ma'am, clear.
Now come to here. So here what happens? When x goes to plus infinity, our graph is going upwards. So that means it is somehow taking the values larger and larger and larger. So that means whenever x goes to plus infinity, our limit will be plus infinity. And when we go to x, when our x goes to minus infinity, our graph is going closer and closer to zero. So that's mean as x goes to minus infinity, our limit is zero, correct? Just
Yes,
opposite
ma'am.
of that.
Yes, ma'am, clear.
Fine. Any doubt? Anyone?
Ma'am, I have a doubt.
Yes.
Uh, can we solve for exponential equation without using logarithms?
I mean, it is too difficult to solve exponential equation without using logarithm, because what happened now, you have to deal what you want to do. We want to do 3 to the power x plus 2 is equals to 0. I want to find such x, right?
Find
So
x.
by graph we say that this won't have a solution. So suppose it is minus 2. So from by graph we know that it will intersect at some point, right? At x-axis.
Yeah. Yeah.
Right, but what happened now, when you have to take that 3 to the power x is equals to 2. So what we want to do, we want to find an x belongs to real number for which 3 to the power x is equals to 2. So if you want to solve it without using logarithm, what you will do, you will take x is equals to 1. Observe what will happen. So when x is equals to 1, 3 to the power 1, it is 3. So it is greater than 2. So that means this is not working, right? And our function is decreasing, right?
Yeah.
So what your guess? So your guess, if I'll take x to be some more left, I can possibly get to my 0, right?
Yeah, x should be less than 1.
So if I'll take minus 1, okay, fine. X should be less than 1, correct? So if I'll take 0, so it will become 3 to the power 0, which is 1, which is strictly less than 2. So that means your X should lie between 0 and 1, right?
Yeah,
So now you have to
I
do
got point.
repetitions as much as you can. I mean, you take 0.02, then observe what is this thing, 0.12, then observe what is. So that's what happen if you take, if you won't take logarithm. I mean, you have to guess it. But log, what will do? So log will give explicit answer that you will learn in next week. Okay. So for
I
now,
can
if
get
you
it.
want to, I think in exercise question, they are just asking that what is the best possible thing you can approach, right?
Yeah,
Okay. So it is clear now.
yeah.
Someone says that explain reversible, irreversible, inverse. You want to?
Yes,
Okay,
ma'am.
fine.
I'm,
Yes.
yeah, I have the same doubt.
Reversible, irreversible, and inverse. So reversible, we know what is the definition, reversible, or it is also known as 1-1, correct? What do you mean by reversible? Suppose we have some space here. This is your domain. And this is your range. And your function is something like a car which is taking someone from here and dropping someone here. This is your function, right? So it is like some car, some taking people from here and then dropping here, right? So what is the definition of function? Anyone could tell what is the precise definition of function?
You can't have two values for the same thing, or two destinations now.
I'm asking function. Okay, fine. So function is nothing but a map from a set A to a set B. Suppose this is your A, this is your B, such that for each x belongs to A, there exists unique y belongs to B, such that f of x is equals to y. This is a precise definition of function. I think you have learned in week 1, but I'm just recalling it. Okay, so this is a definition. So what means this function, what will do? So it just take a person from here and drop it here. Suppose this is set of your person, and this is some set of buildings, right? So what this our function will take? So our function will do, our function will take a person from this space and drop it out in some building, right? It so happen it can take two other persons. Suppose this is our x1 and our x2. So it can take that, it will drop two persons to the same building. Suppose this x1 and x2 are kids and they want to go to schools. So what our function will do, they will uh, it will drop those things to the same building one, correct? This can happen, right? In
Yes,
function this can happen.
Yes,
yes,
ma'am. Yes, ma'am.
yes.
That's I'm telling, that we cannot put a person at same time in two buildings, correct? If suppose this y1 is one building and y2 is another building, so you cannot take a person and put in y1 and also in y2,
Yes,
right?
ma'am.
So that's why the function definition says, in function definition you have two major words. First is each, so that means we have to consider each x belongs to A, and second one is this unique. So that means x should goes to unique y, x should not goes to two y's. This is not possible in function. Okay, so this is one thing. Now go to reversibility. Right. Now what happens if our function will take two person to the same building and we want to go back from this domain to this domain. So from this building we have two things, x1 and x2, right? So then we can get confused which person we have to take and go where. It is not a 1-1 correspondence, right? Okay, fine. Don't go there. Let's just discuss reversibility. Reversibility is something like that. If you have a domain here, a codomain here, and you have a function f, and if you are sending some x to y, then there should a possibility that you can come back. This is what do you mean by reversibility. So that means for x, there exists unique y belongs to fx. And for a y, there exists unique x belongs to, I'm sorry, this is would be range. Unique x belongs to domain. So that means reversible function is defined in this way, that if your f of x1, if your f of x1 is equals to f of x2, then it should happen that x1 should be equals to x2. This is a definition of reversibility you have known, right? Yeah, reversible function are always 1, 1, because that's the meaning of reversible, right? Reversible means if we can take something from domain and go to codomain, we can take the same thing from the codomain and come back to the domain. That's what it means. Reversible.
I have a doubt.
Yes.
Reversible guarantees that it should be 1, 1. But will
Yeah.
1, 1 guarantee that it is reversible?
Yes, it will guarantee, because what happened for unique x, you have unique y. So you'll go to there, and just for that unique y, you have a unique image. So you can come back. But what happens? Suppose I am defining function in this way. Suppose this is 1, 2, 3, 4, and this is C1, C2, C3, right? If I am defining our function in this way, then it is 1, 1, correct? Because
Okay.
for unique thing, but it is not function. Now it is not 1, 1, correct?
Yeah, not 1, 1.
And it is also not reversible, because from C3, I don't know where I have to go. I have to go to 3 or go to 4.
Okay.
Right? So 1, 1 and reversible are same.
Okay.
It is vice versa. We can say that if it is a reversible, then it has to be 1, 1. And if it is 1, 1, then it will be reversible. Ma'am?
Yeah.
And sorry
Yes,
about this
correct.
question. Reversible and
Yes,
inverse
yes.
are not same.
No, reversible and inverse are different.
Okay.
Because I'm audible.
Ma'am, your voice is
So
lagging.
reversible is correct. Reversible is clear to everyone?
Yes,
Yeah,
ma'am.
clear.
Yes,
Ma'am?
someone is saying. Yes.
Ma'am, in a reversible, x1 and x2 is not equal, na? I mean, every value should be unique. Then how it is possible?
Yeah. I mean, I'm writing in the different way. You have written some x1 is not equals to x2. This should implies f of x1 should not equals to x2, right? You're saying this thing, right?
Yes, ma'am.
These two are same. Because what happened? Anyone know something? I mean, suppose your f of x1 is not your f of x1 is equals to x2, right? F of x2. Suppose your f of x1 is equals to f of x2. Then what does this say? This statement means that x1 should be equals to x2, right?
Yes, ma'am.
I mean, this statement and this statement is same.
But ma'am, values are
It is
same,
just
na?
saying p implies q. What?
But ma'am, values are same.
Sorry?
Hello, am I audible?
Yeah. Okay.
Ma'am, values are
Yeah,
same.
you have doubt in this? Okay. Yeah, so I am supposing that values are same, then it will imply that the points are also same. Here what is saying that if points are different, then the values are different. So that means if values are same, then point should be same, right?
Yes, ma'am.
Getting now? These two statements are similar. I mean same. They are mean same thing.
Okay, ma'am.
They are explaining. They are denoting the same thing. But what happened now? Whenever you want to check 1, 1, this statement is more useful, not that much usable.
So we must actually
Yes.
interpret it like this. If f of x1 is equal to f of x2 implies x1 is equal to x2, then they are
Then
reversible.
it will imply
If
x1 is
f of
equals to x2.
x1 is
Yeah.
equal to f of x2 does not imply x1 to be equal to x2, then they are irreversible. That is how it has to be interpreted,
Then
right?
it is not. Yeah.
Okay. So
Yeah,
I mean, so
correct.
the question here is the doubt, the major doubt that occurs in our mind here is we assume that if f of x1 is equal to f of x2, it should be x1 is equal to x2. It's not the case always.
No,
Yeah,
no,
I
it's
understood.
not the case always. For example,
Yes, yes, understood. I
yeah,
understood
you
that.
understand, now. You can take any example where f of x1 is equals to f of x2, but simplest example is f of x is equals to x square. Just take x is equals to -1 and x is equals to +1, right? So for both the values, f of x is equals to 1, correct? But your
Yeah,
x1 is not equals to
understood.
x2.
Yes, yes.
Yeah. So this is the meaning of
Excuse me, ma'am.
reversibility. I'm explaining. Yes.
Ma'am,
Ma'am, can you scroll above,
Yes.
please?
Please, what?
Ma'am, can you scroll above?
Okay. Yeah, yeah.
Ma'am, I have a question like uh, why we cannot write that fx1 is not equal to fx2, then x1 is not equal to x2.
Okay. Yeah, I'm not saying that you cannot write in this way. I'm saying that you can write in this way, you can evaluate in this way, but when you have to do question and there is some function and they ask that find out this function is reversible 1 1 or not, that I'm saying that this is more effective
No, ma'am, these are the
as
two ways
compared
to
to this.
like for the one function. These are the two ways for the
Sorry,
one-to-one
what?
function. I'm saying,
Yeah, these are the
hello, ma'am.
ways for checking a function is 1 1 or not, but this way is more effective. That's why I'm saying.
Yes, ma'am. So for the second point, you've written, ma'am, that
Yeah,
the inputs, if inputs are not equal, then the output will not be equal.
yeah.
I'm
But if
saying,
we
ma'am, why I cannot write it if
yes,
output are equal, then input will not be equal.
the output are equal, then input is not equal. That you are
No,
asking. It is
no,
possible or not?
if output is not
Yes,
equal, then input is not equal. Did you get my?
this can happen now, but the function is not 1 1 then. You are saying if output is equal and input is not equal, right?
No, ma'am. I'm saying that if output is
What?
not equal, like fx1 is not equal to fx2,
Huh? But x1 is equals to
no,
x2.
then x1 is not equal to x2.
Then yeah, this is always true. If it is a function, then this is always true, right? Because two different point can two different point cannot have the same pre-image, right? This is a definition of function. For unique x1,
Ma'am,
you
you're not
observe that in
audible.
this implying
Your voice
output
is
is not.
lagging.
Yes, ma'am.
Okay. Now it is clear.
It's lagging,
Am
ma'am.
I audible now?
You're audible, but the voice was breaking. Okay.
Okay.
Now it's
Sorry
clear.
for that.
Okay. You can proceed.
Maybe. Okay. So what happen if you are saying that f of x1 is not equals to f of x2, then this always imply that x1 is not equals to x2 if f is function. That is the definition of function, right? That two different members in range cannot have the same pre-image. That's why I'm saying that. That's why I'm emphasizing this word each and unique. Yeah, this
Ma'am, there
each
was a
x has a
question
unique y.
activity.
What? Hello?
ma'am, can
Yes,
you scroll up
Yeah,
till definition of reverse?
definition of reversible, yes.
No, not. Um, yeah, this one, man. Here, f of x implies y, right?
Okay,
In
let me
that
get
case,
back to you. Three statements. Okay. Fine.
it is also
So
on to
case
then.
first. No. F of x1 is equals to f of x2 will imply x1 is equals to x2. F of x1 is not equals to f of x2. This will imply x1 is not equals to x2. F of x1 not equals to f of x2 will imply x1 is equals to x2. And f of x1 is equals to f of x2 will imply x1 is not equal to x2, right? I'm giving you this 4 options, 1, 2, 3, 4, and I'm saying that your function f, your f is a function. Then which option is always true? Just tell me this question. Just think about it. Remember, what do you mean by a function? If something is defined to be a function, what is the definition of that?
Second one.
Second one always the case, right?
Ma'am, except for all can be possible.
What?
For a function, except for all options can be possible, because different pre-images can't map to a single image.
Okay. Someone is saying also 3. Sorry, 1 and 2 is possible. 1 and 2 is not possible. I'll give you examples. Okay, then it will be more clear. Okay, for 1, you guys understand what do you mean by a function, right?
Yeah.
I will recall it once again. What do you mean by a function? Just remember what do you mean by a function. Okay. So function is what? Function, you can think like a machine which takes something from some place and gives something some output. But what happened? It can take only one piece at a time. It cannot take 2 pieces at a time and send it into some place. Okay. So function is nothing but a map from A to B, such that for each x belongs to A, there exists unique y belongs to B. Just remember these two words, each and unique. Okay, so first option, what is first option says that you have two things which is similar to in range, and we this will implies that x1 is equals to x2. This is a condition for reversible, right? Right? So if it is just given that f is a function, that it is not always the case. For example, wait, the first function is also. For example, just take f of x is equals to x squared. Then what happens? Then if you take x1 to be 1 and x2 to be -1, then f of x1 is equals to f of x2 is equals to 1. But f of x1 is equals to f of x2 is not implying x1 is equals to x2, right? So this statement is not always true when f is a function, correct? Am I audible clearly?
Yes, ma'am.
We're just thinking. Okay.
Okay, fine. So you got my first point, right? F is a function, but it says that f of x1 is equals to f of x2, but x1 is not equals to x2 in this case, correct? So that means this statement is not true. This thing won't imply x1 is equals to x2 always, if we are just given to be a function, correct?
It is a bit confusing. Like, I mean, isn't that a function, the first one?
Yeah, it will be a function.
Okay.
Uh,
It will not be not necessarily
yeah.
reversible. That's what you mean.
Yeah, it not necessarily, I mean, if you are just giving that it is a function, then it is not always true. What I'm asking, which of the thing is always true in any
Oh,
case?
okay.
Yeah. So it is not always true. There could exist some functions which does not satisfy this property. In mathematics, what happens, this I'm telling you, if you are given some statement here and there is a sign of implication, and you are given some statement here. Suppose this is your statement A and here this is your statement B. So what you have to do, you have to assume these things. Assume these things are true, and then you have to check this thing as true or not. For example, here what I am saying, that f of x1 is equals to f of x2. So first find an example for which this is true, but your x1 is not equals to x2. But then in this case, the statement is not true, because it says that if this is true, then this should be equals to true. This x1 and x2 should be equals to 7, right?
Oh, so you're saying the statement is not true. Okay, understood. Okay,
Yeah, the statement is not true. Correct?
okay.
Everyone is understood, or should I repeat? Got it. Okay, fine. Now go through the second statement. What the second statement says? That f of x1 not equals to f of x2 will imply x1 is not equals to x2. Is this true always? This is always true in case of function.
Ma'am, but it is given a false statement in the activity question.
For reversible, it is not true. For being a function, it is true. If
Ma'am,
you
it is
if you
given.
want,
You mean the second
yes,
statement? The second statement.
this should be given for reversible, because what happened if you have two distinct images, then yeah, sorry. So that's why I'm telling that it's true.
No, now there are two cases here. One, is it a function? The other one, is it reversible? So what are
Yeah, so it
we?
is. Yeah, it is a function, but it is not reversible. That's why I'm saying.
Okay.
Yeah. Okay.
I mean, why would you say it is not reversible? Because if x1 is not equal to x2, then f of x1 is not equal to f of x2. So that means uh, everything are one to one, right?
F of x.
I think it should be
No, it
a
is not.
function as well as reversible, isn't it?
No, it won't be reversible, because what happened now? Mm, f of x1 is not equals to x. F of x2 will imply x1 is not equals to x2. This is not the case. We want this statement to be true. This will be 1 1, but it is not reversible. So I will find an example. Just give me a minute.
Ma'am, I have shared a activity question screenshot.
Okay. So
No, but you said if it is 1 1, it
Section.
will be reversible, isn't it?
yeah, 1 1 means reversible.
Yeah, and that second statement implies it should be 1 1.
Which question,
Second
Milika?
statement here.
Oh, sorry.
Question 4.
Oh, something else.
Question 4, the last one. A function is called 1 to 1 if a function is called which of the following is false. It is asking that it is false now. So it is false. Right.
But
What
ma'am,
you are saying? Yes.
you told na it is true.
No, I am telling that. Wait, you guys are getting confused between function and reversible. I am telling that it is true. Here we are given f is function. Need not to be reversible. Now it is clear. Now this statement is true for function, not for reversibility. I mean, someone is saying that f of x1 is not equals to f of x2 will imply x1 is not equals to x2. This condition will not imply that our function is 1 1, because there
Why?
is some yeah, and this give me a minute, I'll find a counter example.
Okay.
Something like that. So reversible. But in this case, it is not a function. So if x1 is equals to x2, this will imply f of x1 equals to f of x2. So f of x1 is not going this way. Yeah, this is correct. But this should not be the case of reversibility. I mean, we want other way around. F of x1, x2 is same. Okay. So this is not true in general. I'll just find an example and tell you in
Okay.
some time, okay? But I'm 100% sure that this is not the case for reversibility. This won't imply reversal. Why? Because for reversibility, what we have this statement that x1 not equals to x2 will imply f of x1 not equals to x2, right?
I mean, the
And
other, I mean,
here
the opposite way.
yeah, and this
Isn't
situation
it?
says that
Isn't this the same statement there?
no, f of x1 not f of x1 not equals to f of x2 implies x1 is x1 not equals to x2. This statement is far away different, okay? Just don't
Oh,
think these are the simple same
then
statement.
how
They
can
are
they be
not,
different?
because here hypothesis and your result, this is your input and your output is different, right? Here both are
Okay.
the inputs are different and outputs are also different. I'll find out the counter example, but in I'm finding the counter example. Suppose you
Okay.
have this type of thing that 1 2
Oh,
3
it could be, I
and
mean, for the second statement, then for f of x1, you may have some other x3, which is
yeah,
equal to x1. I mean,
yeah.
is it something like
Uh,
that?
yeah, this can be happen, correct? Because f of x1 not equals to f of x3, x2, but there could exist some x3
Yeah.
for which this thing,
x1 may
but
be
in
equal to x3.
yeah, x1 may be equals to x2. Correct. Sorry.
Okay.
Now I'm getting.
Okay.
So that's why when first of all you always have to go through the definitions and go through the whatever condition is given to you. You cannot just
Hmm.
listen. In this statement, there are so many different things are happening. Here input is different. Here output is different. This statement is totally different from this statement. It is not even though negation also.
Hmm. No, I mean,
Okay.
this
So
is something
whenever
new
you
to me today because I always assume
yeah.
x1 not equal to x2, implying the f of x1 not equal to. Okay.
No. This is not the
Okay.
case. This
Okay.
is not the case. Okay. So we are running out of time. I'm just clear. Just lastly state what is the reversibility. Just forget about the above question, but I will discuss in more detail also. I'll
No,
just
no, no.
collect all the
That was
counter
quite valid.
examples.
Very enlightening. I mean, very important too.
Yeah. So reversible. So for reversibility, you have two statements. First of all, it is given that it is a function. You have to check it is reversible or not. So you have two statements. First statement says that if f of x1 is equals to f of x2, this will imply x1 is equals to x2. And the second statement says that x1 not equals to x2 will imply f of x1 not equals to f of x2. These two are the tools for checking your function is 1 or not. Okay, this much is clear. You can use any of them, but I'll prefer to use this one, or anyone will prefer to use this one. When you do the example, you will understand why. Okay.
Oh, okay.
It is clear to everyone now, and the people are going now.
Yeah, understood. I
Yes,
mean,
ma'am, clear.
Okay, fine. So this is the condition for reversibility. Now, what do you mean by inverse? So inverse means a function should be reversible. First of all, we have a function, then we have a reversible, and then we have onto. What do you mean by onto? Onto means if you have a function from A to B, then
So
for
domain is equal
any
to.
B belongs to B, we are able to find and A belongs to A such that f of A is equals to B. So that means every B has a pre-image, correct?
Yes,
So when
ma'am.
a function possesses these three properties, mainly these two properties, reversibility and ontoness, then that function is said to be inverse. Correct? Got
Ma'am,
it?
can you repeat?
yeah.
Okay. So a function is said to be invertible or
Inverse.
invertible if it is 1 and onto.
Okay. And what is the third point?
No, third point, I'm just saying that it is a function, but if you are given that it is a function, then we don't need to
Okay.
check it.
Okay. Okay.
Yeah. So if a function satisfies reversibility plus ontoness, then it will be an invertible function. That was I'm saying. Clear?
Okay, ma'am.
Ma'am, so we can say that surjective functions are inverse functions.
No, you cannot say, because you
I did,
want invertibility also. For example,
I mean a bijective, sorry.
yeah, bijective is the name for inverse also. Okay, bijective and invertible are same. Bijective function are always invertible, because bijective is something which says invertible. Invertible, bijective, they are same. Okay, so any doubt in invertibility or checking one-to-one? Whenever you have to check one-to-one, you just apply this thing or this thing, preferably this thing. Okay, whenever you need to check onto,
Ma'am, your
what
voice
you
is
have to do, you have to take an A such that f of A is equals to B. Okay.
Ma'am, please repeat again.
Okay. So I am saying, if you want to check your function is invertible, you have to check two things. You have to check it is 1, 1, and second thing, you have to check it is onto, right? For 1, 1, we have a simple condition that if f of x1 is equals to f of x2 will imply x1 is equals to x2, then our function is 1, 1, correct?
Yeah,
For
ma'am.
1, 1, you have explicit expression to evaluate, correct?
Yes.
Ma'am.
That f of x1 is equals to f of x2 will imply x1 is equals to x2. If this is true, then it is 1, 1, otherwise not. Okay. Now for onto, it is a little bit tough work. I mean, what you have to do, suppose you have a function from A to B, then for each B in B, you have to find an A in A such a way that f of A is equals to B. Or in some sense, you have to show that your range of f is same as codomain. You know this terminology, right?
yes.
Codomain, domain, range, right?
We know, but it takes time to get in. Okay.
Yeah. For example, suppose if you have a function, suppose if I am defining f is a function from R to R, such that f of x is equals to x square, right? This is a function, correct?
Yeah, ma'am.
Yeah.
But what is the domain? Domain is the whole R.
Mm. Yeah.
What is the range?
Positive.
Range is what?
0 to infinity.
R plus, correct? 0 to infinity. And what is the codomain?
All real values.
All
Codomain
real.
is again R. Yeah.
Yeah, codomain means this set.
Yeah.
Okay, so in this case, your range is not equals to codomain. So your function is not onto.
Mm. When here it was kind of easy to find out.
Yeah, yeah, ontoness always required some effort to prove.
Okay.
So that's the thing. You have discussed all these things in the last session, right?
No, not this.
This is stuff from first week, I guess. That's why. Fine. Don't worry. So now it is clear, 1, 1 onto invertible. Or should I spend some more time?
No, it's clear. Conceptually, it's clear, but
Yeah.
we aren't confident.
Okay. Yeah. Fine. Just do some examples, or it will take time.
Okay.
That's the thing about abstract maths. When you have to deal with such kind of statement,
Yeah.
it will take
So
time to
when you
digest.
read the
So
question, that itself takes some time to
yeah.
comprehend. Yeah.
So don't worry. It will become more handy once you pass
Practice.
2 or 3 weeks also.
Okay.
So, okay.
Ma'am,
So
can
I
you
think
please
Ma'am, can you
share?
share your document?
Yes, ma'am. This PDF.
what this PDF I have to
Yes, ma'am.
share.
Yes, ma'am,
Okay. So
please.
I'll. Is there any way to share in Zoom? I'll.
Ma'am, just drop
Okay. Okay.
your
So,
document.
if anyone has any doubt, I can discuss up to 10 minutes also. So, if you have doubt, then please tell. Otherwise, I'll end the session. No doubts? Okay. Fine. So you guys want to give some feedback about the class? Any feedback for me?
Yes, ma'am. Absolutely
Yes.
great.
Going too fast, too slow, or confused?
No,
Ma'am,
no, we
moderate.
found it quite comfortable.
Okay. I will appreciate negative remarks also because.
No, ma'am,
Ma'am,
it's
but
just
your
that we are
network
reading.
sometime was lagging.
Oh,
Yeah.
network issue. I'll fix it tomorrow. Don't worry. So that I'll do.
Yes, ma'am. Ma'am, sessions are very helpful. It's just that we are reading first time, so it takes
Yeah,
time to
yeah, that I'll
catch.
understand.
Yeah,
It
ma'am,
will
sessions are very helpful.
yeah. Thank you. Just I'm just saying, just be thorough with the definition. Definition will take care of 90% of your problem in question sheets or problem sheet or activity questions. As much as you can remember or mug it up, that will also helpful to you. But just don't miss any single word from the definition. It is important in maths. That's what I'm saying.
Ma'am, are you sharing the PDF?
Yeah, I'm sharing. Just downloaded it. One. So I have shared the PDF. Just check it in chat. Okay. So uh, again, any remark on class? Anything I can improve or something else? Anyone wants to say something, you can say.
No, what does POD means?
Oh, we have given some post here, so that's the POD. When there are levels, we have PODs, TAs, mentors, professors. Professors are actually professors, but below professors, we have some other.
Ma'am, POD
You
stands
can say
for
rank. What?
POD stands for full form.
Actually, I don't know, so just given PODs.
No problem.
I will let you know in next session.
Okay.
Okay, ma'am.
Any other remark that I'm going too fast, too
No, no,
slow?
no. You're perfect. Like you're quite patient also.
Okay.
Ma'am, can I ask one question
Yes.
of the context? Ma'am, are you also studying in IIT Madras?
I don't know. Yeah, actually, I am, but it won't help. I mean, yeah, I'm studying in IIT Madras.
Okay, ma'am.
Okay, then we'll stop the session.
Ma'am, BS degree
No.
on campus.
Yeah, in the campus. I'm doing some official courses,
Oh, great, ma'am.
masters and all.
Okay, ma'am.
Just I'm just telling you one thing that whenever you study mathematics and you come across some definition or remark, just learn it and just observe each single word because it matters. So that's one thing you should always understand. And in
Okay, ma'am.
mathematics, there is no illogical thing will never happen. If something is happening, there is always some reason or some definition or some result behind that. So that you should keep in mind. Okay. If you don't understand that why it is happening, so that means you should ask. Okay.
Yeah, ma'am.
You can leave now.
Thank you, ma'am.
Thank you.
Good night, ma'am.
Good night.
Ma'am,
Yes.
ma'am, can we learn geometry in upcoming weeks? In
Geometry, I mean,
integration, those are much interesting.
you will learn how to compute area, and
Mm,
that's it. That's all geometry you can able to learn.
area means mensuration, or do you mean integration?
Yeah, doing using integration. You will learn that in ninth or
Calculus.
10th week, because that's only things you needed. So whatever you needed, you will teach, but you don't need any geometrical aspect. I mean, no triangle, rectangle, and so on. I mean, no
Mm,
angles, other things.
trigonometry.
Trigonometry you don't need after. I mean, you just need that basic sine, cos, tan, thetas. You don't need anything more than that.
Yeah, because I'm very much interested in pure max more
Pure
than,
mathematics.
yeah, like
Uh,
geometry.
okay, but in this course you don't have to learn. You're not able to learn pure mathematics in this course. Because
Like,
you are prepared for data structure algorithms now. So in
uh,
data structure algorithm there are more, mainly graph theory and some calculus and some Riemann integrable and set theory. That's all you needed. So, and linear algebra obviously. So linear algebra you will see in math 2 course.
linear algebra, graph theory, and calculus. That's it.
Yeah, that's it. Mostly that will be
Mm,
the domain. One or two topics from other things also.
okay. If I want to learn geometry on or pure max more, then can I do masters after this
Yeah,
program?
you know what about geometry? So geometry will start basic geometry we have learned till sixth
Yeah,
class.
that's a very
After that,
very nice
geometry
thing.
will somehow convert into analysis. When you go in masters in mathematics, what happen?
Mm.
You will learn geometry, but there is no geometry there. I mean, there is a purely analysis thing will happen in geometry also. So you have interest in geometry. I mean, you have interest in some
Yeah, yeah,
spheres and all.
trigonometry and geometry, angles, no,
Yeah, angles and all those
pure
stuff.
max,
No?
pure max means first.
Hmm. You can
Because
do it.
I did a research also in trigonometry. No.
Sorry, what?
During my 10th, I used to do research with trigonometry.
Okay,
Lots of it.
okay. Nice. You can go. I mean, just explore whatever thing you have to do in masters and you can do it.
Come on. Good night.
Good night.
Ma'am, you are in PG now?
Yeah.
Okay, ma'am.
So you can leave. I'm just waiting for ending this session. So, सेशन खत्म हो गया है बट उनने एंड नहीं किया है तो मैं लीव कर दूं या रुको थोड़ी देर ओके थैंक यू